Alright, in this video I want to demonstrate how to find the slope of a tangent line at a particular point. Alright, in this case at point P, which is -4, -1 of a given function. It's a rational function, 4 over x. And then we're going to determine the equation of the tangent line at a particular point. And oftentimes we want that equation in slope-intercept form, so y equals mx plus b. So that's the form I'm going to stick that equation in. Okay. But first, let me quickly review finding a derivative as a limit. All right. So assuming that you don't know the derivative rules just yet, and we're forced to use this difference quotient here, as h approaches 0, let's find the first derivative of our function, which you should know by now that this is going to give us the slope. All right, the first derivative always gives us the slope of a tangent line. All right, that's really important. The first derivative always gives us the slope of a tangent line at any particular point. In our case, it's going to be point P. Alright, so I've got this thing here memorized, and to really dive into this, I already know what the function f of x is. They gave me that right up here, 4 over x. What I don't know is, I don't know what f of x plus h is. So let me go find that first, because I need to plug that into this formula as well as the rest of it here, right? H is all by itself on the bottom. So let's first go find f of x plus h. Alright, so I'm going to do that right here. I know what f of x is. That's 4 over x, right? We were given that. Let's go find what f of x plus h is. Well, that simply means that anywhere I see an x, I need to plug in instead. I need to plug in this new independent variable, which is x plus h. Okay, no problem. It's just going to be 4 over, instead of x, 4 over x plus h. Okay? So whatever's inside this parentheses, that's what is being replaced with this x here. That's what x is being replaced with, rather. Okay, so I've got both players now for that formula for my limit here. I've got my f of x plus h, I've got my f of x. I already know what h is, so I'm good to go. I'm going to start filling in this limit. To do that here, let me just slide this down so you can see this. I'm going to say, alright, that slope of the tangent line is equal to the limit as h approaches 0, right, of my f of x plus h, that's this function here, which is simply 4 over x plus h, minus my f of x function, which is just 4 over x, all over, right, all over h. This is what we call a complex fraction, because I've got fractions inside of fractions here. And you know that right now I cannot just substitute 0 in place of h, because I'd be dividing by 0, and I can't do that. So to put 0 in place of h, I should be able to simplify this complex fraction first. Alright, let's ignore the denominator. Let's concentrate on just the numerator stuff. And to do that, I need to subtract those two fractions. And to subtract fractions, I need an LCD. Okay, so let's see. My LCD is going to be, slide this down a little bit more. My LCD is going to be, how about both of them? X plus h and x. Right, so it's going to be both of them. And since this first denominator doesn't have an x, right, all it has is an x plus h, so it's missing this missing term. It's missing just the x. I'm going to multiply the top by x as well. So my new numerator is 4x. This denominator already had just the x, but it was missing the x plus h, so I'm going to multiply its numerator up here by x plus h, and so I have 4 times x plus h. Right, again, this is all being divided by, right? See this division right here? It's all being divided by h. Well, how about if I write it this way, divided by h? You guys okay with that? And you know that if I was to write this as a fraction by putting it over 1, you know that we don't divide fractions, we actually multiply and flip, right? So I need to flip this second fraction here. Alright, so what I have then now is this. Let me start a new sheet here. What I have is, I've got 4x minus 4 times x plus h all over x plus h times x times, and I'm going to flip this h, instead of divided by h, I'm going to write it as times 1 over h, right? That's a 1 on top. And while I'm at it, I might as well distribute this out here. this negative 4, so I've got really, right, I've got 4x minus 4h all over these two things, x and x plus h times 1 over h. And I hope you can see pretty easily that my 4x's cross each other out. 4x minus 4x, well, that's just 0. They're out of here. And this h right here that's all by itself on top, that's being multiplied by negative 4, and this h down here cross each other out, since rules for simplifying fractions apply here now. And so I'm finally left with, in the numerator, a negative 4, just this thing right here. And in my denominator, I've got both an x and an x plus h. All right. So I hope you see that I did all of this work to simplify my original complex fraction so that I can go back to the limit as h approaches 0. This thing. And now it's perfectly okay to substitute 0 in place of h. Right? It's perfectly okay to do that. If I pop in a 0 right there, I hope you see that I really have x plus 0, which is just x, and this x times that x leaves me with an x squared on the bottom. So all of this shrinks down to negative 4 over x squared. Now again, remember what we were given at the very beginning of the problem was to plug in this point of negative 4 comma negative 1, right? P at negative 4 comma negative 1, which means my x value, right, my x value is a negative 4. Okay, so in place of x squared, I'm going to stick in negative 4. I'm actually going to evaluate this out. So the slope of the tangent line is equal to negative 4 over x squared. But again, instead of x, I'm popping in a negative 4 because that was what the x part of the coordinate was going to be, which is just a negative 4 over 16, or simplified is negative 1/4. Alright, so there's the answer to part A. The answer to part A is the slope of the tangent line, right? The slope of the tangent line is a negative 1/4 right here. So part B is saying, alright, well now that you know the slope, can you tell me what the full equation is? Okay, now that we know what the slope is, now that we know what m is, can you tell me what the full equation is going to be at that point of negative 4, negative 1? Well, we can do that pretty easily. We can use the point slope form, right? The point slope form of an equation. Point slope form of an equation of a line. And that looks simply like this. Y minus y sub 1 is equal to m times x minus x sub 1. And the three variables here that I'm going to replace, right, is this one, and this one. I'm going to replace all three of these. Everything else pretty much stays exactly the same. So it's going to be y minus, now was I given a y coordinate, a y part of the coordinate? Yeah, I was. I was given the negative 1, right? This is the y portion of the coordinate. So I'm going to plug in negative 1 in place of this y right here, y sub 1. I know what my slope is now. My slope was negative 1/4. I just found that using my derivative limit. And I've got x minus, right, so I replace that, and I hope you see I'm going to replace, in place of x sub 1, the x part of my coordinate, which is negative 4. Okay, so I've got a negative 4 going on in there. Alright, so to clean all this up, and I'm almost done, the last thing is I just want to get y all by itself and everybody else on the other side. So let's see here. I really have y minus a negative 1, which is plus 1, is equal to, this is really x plus 4 inside this parentheses here, and I'm going to distribute this negative 1/4 to both of these guys. I know I'm moving kind of fast here. Let's see, and negative 1/4 times a positive 4 is simply just a negative 1. Alright, last thing, here we go. Let's get this y all by itself by moving this positive 1 over to the other side. It becomes a negative 1. Final answer then is y equals negative 1/4 x minus 2. That is the equation of the line that touches at point P of negative 4 comma negative 1. That is the equation of the tangent line. Right? That's the equation of the tangent line at that given point right there of negative 4 comma negative 1. Hope that helps.